Welcome to Module 4. Here we're going to talk about integrating security in the DevSecOps pipeline at the coding stage. Gets a little fun here watching things kick off and automatically reject code due to problems with the developers with some of the tools out there, and we'll look at them. So our learning objectives, we're going to learn to integrate security plugins within the interactive development environments. We'll learn to configure and manage code scanning for GitHub repositories. We'll learn to integrate and scan source code repositories and integrate secret management tools. We'll also integrate software composition analysis or SCA tools. We'll integrate SCA tools with IDE. We'll learn to integrate SCA tools with source code repositories. We'll learn to integrate SCA tools with Travis CI, Jenkins, and GitLab. We'll learn to integrate SCA tools with AWS. And we'll also learn to integrate SCA tools with Microsoft Azure. Now, since you do have hands-on labs, some of these integrations will just show you the basic steps and kind of talk through it a little bit without going into the great detail of what each command line would do or things like that. You'll have that in the labs. So let's look at DevSecOps code strategy or code staging security activities. The development team is responsible for writing code to implement the features and functionality as per the plan. The team needs to implement cryptographic functions and various security features designed within that plan. Along with the standard security development toolkit, the developers need to integrate various plugins to collaborate with the team and maintain consistency in the code base by implementing good coding practices. Developers need to identify and resolve bugs that may fail the build, requiring the integration of security plugins with the IDE. This will help identify potential vulnerabilities in the code in third-party libraries. Integrating pre-commit hooks and secret management tools in the source code repository ensures that the push code does not contain sensitive information, such as authentication keys, etc., as we discussed in the last module. Let's go on with Lesson 1. Learn to integrate security plugins in IDEs. There's a need for integrating security plugins within the integrated development environments. Since developers are responsible for mitigating the vulnerabilities caused by their code, having these security plugins in the IDE enables them to check for security code flaws while they code. These security plugins help identify the security flaws and bugs in the developer's code by scanning the open source dependencies and third-party tools for security issues, thereby helping with the delivery of secure applications very quickly. There are various security plugins such as SonarLint, CodeSonar, Fortified Clockwork, SSV Checker, Secure Assist, and FindBugs, which support the various interactive development environments that we deal with. Each plugin has a different method for integrating with the IDEs. The IDE security plugin scans and analyzes the code while it's being written. It provides notification to the developer about the security issues and typically recommends how to remediate a specific security issue. So basically, we look down below and you see that you boot up the device where the IDE will be set up. You download and install the required programs to set that environment up, and it interacts with the IDE via text editor. And this is basic coding using the developer device or the local host for doing your coding. Let's look at security plugin. One of them is SonarLint. SonarLint is an open source IDE extension that detects and remediates security issues during the code development. It provides instant feedback and recommendations to mitigate the security issues, which helps the developer in producing robust software products. It highlights all the impacted locations in the application code to help developers in finding and fixing the security issues with ease. SonarLint detects common mistakes, little tricky bugs, and known vulnerabilities. It can be integrated with Eclipse, IntelliJ, Visual Studio, and VS Code IDE environments. Some of the major languages that it can analyze include Java, JavaScript, TypeScript, PHP, C#, Python, Ruby, HTML, and VB.NET. So on the left, you see remediation guidance and the feedback on the right that it gave you. You know, if a bug is discovered, it'll recommend what you should do about it. And on the right are the feedbacks. You had these 9 parameters, which is greater than an authorized threshold or limit. In order to integrate SonarLint with some IDEs, one of them to look at is Eclipse. It's basically one of the more popular and common used environments. The method that's used for installing SonarLint, you use the Eclipse Marketplace, use the drag and drop options in Eclipse Marketplace. You drag and drop the install button into the Eclipse workspace. It will download and install the plugin. Use the installation of the new software option in Eclipse. How do we do that? You simply go to Help, Install New Software, and type eclipsesonarlint.org on the wizard. So first of all, you see installing using the Eclipse Marketplace. You go through the new software installation wizard. You do on-the-fly reported issues in the opened and edited files. You can review the highlighted issues in the editor, and then you can review the rule description. In the first panel, it shows installing the SonarLint security plugin. Then you see having an access rules description and what you're going to apply to it. And as you're coding along, you can see and view the highlighted issues within the editor, and look at the error list panel, which displays all the errors within the code of what you're doing. You can also do this in the VS Code IDE, and it's very, very similar. You have a review of the rules description. You view highlighted issues in the editor, and you can display all issues again throughout the code wherever it's found. Looking at SonarLint in IntelliJ IDEA, the same type of panels are reviewed. So it's very consistent across all the IDEs as far as what you see, how you manage vulnerabilities, when they pop up, what they look like, etc. So it's got the same pretty much look and feel as you move from IDE to IDE. Let's talk a little bit about JFrog. So JFrog IDE integrations allows the developer to, again, detect security and compliance issues in the source code. Using the plugins or an extension, you can scan the project dependencies and view security issues during SDLC. JFrog supports the following IDEs. Currently can be integrated with 4 primary IDE environments, and it works in all 4 environments with the same 4 functionalities. So you have Visual Studio Code. In this IDE, it scans Python, Maven, NPM, and Go project dependencies. When integrated with IntelliJ, JFrog scans Go, Gradle, Maven, NPM, and PyPy project dependencies. In addition, it can support PyCharm, Golang, WebStorm, and Android Studio. Within Eclipse, JFrog can scan Grade, NPM, and Maven project dependencies. And in Visual Studio, JFrog scans the NuGet project dependencies. So if we look at JFrog and Eclipse as the IDE plugin, it'll add JFrog X-ray scans of Gradle, NPM, and Maven project dependencies within your Eclipse IDE environment. With this integration of the JFrog Eclipse IDE plugin, the developer can view the vulnerability information related to the component and its dependencies directly in the IDE environment. This will help the developer to decide whether to use the component before incorporating it into the software product. The steps for installing and configuring JFrog Eclipse IDE plugins. First, you install the plugin. If JFrog is behind a proxy, then of course you have to set up proxy or you have to put in the proxy settings. For connecting to JFrog X-Ray, you set up the plugin. Next, perform the scan and view those results. Then filter the X-Ray scanned results. Down below, you can see the scanned results according to issue or licenses. Over on the right, you see the connection to the plugin to the instance of JFrog X-Ray. If you want to use JFrog in the Microsoft Visual Studio, the developer can integrate the Visual Studio IDE with JFrog tools Using the JFrog Visual Studio extension. This extension will help the developer gain critical insights regarding the security issues detected by JFrog X-Ray in the NuGet packages. So how do you install and configure JFrog within Visual Studio? You enter the NuGet command in the terminal. If it's not recognized as the correct command, go to the path environment variable and add NuGet.exe. Then you open Visual Studio. Navigate to Tools, then go to the extension and Updates. Search for JFrog and download it. After successfully completing the installation, you can restart Visual Studio. So on the left, you can see the downloading the JFrog extension in Visual Studio, and on the right are the scanned results according to issue severity once you run it, or as it runs. So up here we have the preference window of the URL, username, password, etc. for the JFrog credentials, and you'll choose your preferences of what you want to look at. Choose JFrog for the analysis tool. It'll run and give you a review of issues. You can actually kind of drill down into license info as well on what you're analyzing. You can perform scan and view results using JFrog Visual Studio. For scanning and viewing the project dependencies using JFrog, open View, Other Windows, JFrog. If you open the project or click on the refresh button in JFrog window, JFrog X-Ray will automatically run the scan on the source code. You can see that down below, scan and view the project dependencies. Then you can filter the scanned results. Use the filter provided by JFrog extension for narrowing down the scanned results and viewing the desired findings. You can go by all, critical, major, minor, unknown, or normal. You can also use the Deep Code security plugin for Visual Studio Code for the Visual Studio IDE. And basically, you use it to perform source code reviews again and do quick analysis of the Visual Studio Code IDE. When you hit the Save button in the IDE, you'll receive an automatic alert about the critical vulnerabilities detected in the source code by Deep Code. Using the Deep Code extension, you can quickly find and remediate the bugs in the source code before deploying the application to your production environment. The Deep Code extension will scan the code that is not stored in a repository yet. It will gather the code files and send them for analysis. In addition, the extension gives a provision for the developer to define the back-end infrastructure that needs to be used. So on the left, you can see installing Deep Code and the VS Code, and statistics and suggested files are on the right. The Microsoft Code Analysis extension will also provide live analysis of the code while you're developing it. Using Control+, you can quickly remediate the identified security issues in the code. The extension offers diagnostics for security, performance, API design, etc. The diagnostics will appear in the error list, editor, and scroll bar. So on the left, you can see choosing code analysis. You'd choose Microsoft All Rules. You'd run the code analysis and analyze what the output. Up here you have the error list window. What did it find? It found some naming convention errors in this instance. You can double click on an error to navigate to the specific location within the code editor to quickly get to the point where you need to resolve the issue. Here you suppress the code analysis warnings if you want to, and you can implement the suggested correction. And here it happens to be choose to rename. Once that's done, you can observe the code and you can do a live code analysis and a quick fix of it. So it's fairly process-driven, step-driven, very graphical kind of an environment. Let's look at Fortify. Fortify Static Code Analyzer plugin for Visual Studio uses the Micro Focus Fortify Static Code Analyzer and the Fortify Secure Coding Rule packs to locate security vulnerabilities in your solutions and projects. Fortify supports C, C++, C#, VBNet, and ASP.NET. The scan results show a list of issues uncovered, descriptions of the types of vulnerability for each issue that it represents, and suggestions for fixing them. The extension is included with the SCA installer. So you'd select Analyze Solution option. You next choose Analyze Project. You analyze the issues using Fortify Static Code Analyzer plugin. Then you review the details of the issue. Let's look at Microsoft DevSkin. DevSkim is a framework of language analyzers and IDE plugins that offer inline security analysis while a developer develops the code, much as we've talked about before. It supports a variety of programming languages. DevSkin immediately notifies the developer if a security issue is introduced into the code. The issues will be highlighted in the source code with the links that provide further information regarding the vulnerabilities. DevSkin helps developers to quickly mitigate security issues and develop awareness among them regarding potential security flaws. So here you have identified security issues in the description. So you're coding along and this will pop up. And then it'll also, if you click on it, it'll also provide issue suggestions on how to deal with it. So what about PyCharm? The PyCharm security plugin will identify vulnerabilities in Python application code and provide recommendations on how to remediate them, much as the other ones do. To install the PyCharm security plugin in the PyCharm IDE, go to Preferences, navigate and click on Plugins, and type Python Security in the search box. Select Python Security, click on Install, and click the OK button. Then you restart the IDE. You open the application code, click on Tools in the menu bar, and navigate and click on Check Python Package Security. Once you've done that, it'll run, and then you can click on PyCharm Event Log to view the detected security issues in the Python application code. And here you can see the vulnerabilities that were discovered, and they're brought to you in CVE form. All right, so let's talk about integration of security IDE plugins to cloud-native IDEs. And basically, we're talking like AWS and Azure, etc. Insecure application configurations in infrastructure and container vulnerabilities are the primary attack vectors in the cloud environment. Using infrastructure as code, or IAC, for quick deployment in multiple cloud environments can result in insecure configurations that could possibly get deployed. The security that's applied to the cloud-native application should ensure that the application vulnerabilities are identified and mitigated while being developed. Like, it fits right in with the flow of what we're talking about right now. Integrating security IDE plugins into the developer's IDE will help developers fix and find these vulnerabilities rather quickly. So basically, when you're coding in the cloud, you're going to boot up the device that you're coding from. You open the browser and access IDE in the cloud. Using the browser JavaScript, user WebSockets to initiate the secure communications channels, etc., are done in the background so you can access your online IDE. Once this is completed, you can interact with your IDE via the text editor in the browser. So let's talk about White Hat Sentinel Eclipse plugin for the Eclipse IDE. The White Hat Sentinel Eclipse plugin also allows the DevSecOps teams to detect vulnerabilities in the application code, source code location, etc., and provide suggestions to fix the vulnerabilities. The DevSecOps team can install and configure White Hat Sentinel Eclipse plugin by searching and selecting the White Hat plugin in the available software window. And you can see that on the right. Select the application that you want scanned and click on the filter icon. Observe the vulnerabilities present in the application code, and then you can check out the recommended changes to the application code in order to mitigate the vulnerability. So there you see Manage Application for Vulnerabilities, and down is Scan Application for Vulnerabilities. You can use the white source advice to scan application code in the Visual Studio Code IDE as well. Using it in Visual Code IDE, the DevSecOps teams can perform the security vulnerability scans in the application code like we've been discussing. The team can perform either complete scans on the workspace or selected folders in the workspace. After completion of the scan, a notification is displayed, providing information of the discovered security vulnerabilities. To gain more information regarding the vulnerability, the team can click on Show Problems inside the notification, and you'll get some details about what was found. So here we're looking at integrating the White Source Advice IDE security plugin in VS Code IDE for Microsoft Azure cloud environments. And again, we've talked about White Source and what it can do to send real-time alerts to the developers while they're developing their code. But the DevSecOps team can install and configure White Source Advice through the Visual Studio Code Marketplace. You link the Visual Studio Code with the Azure DevOps remote repository to push the code in Microsoft Azure. You can see that on the right with the plugin download. We can also look at AWS and SNCS IDE integrated check. SNCS IDE integrated check also detects those same vulnerabilities that we've been talking about in open source dependencies early in the development of the cycle by scanning directly from the developers' workstations, thereby minimizing development time and effort on future fixes in the AWS ecosystem. And this is SNCS version of the same thing that you see in this UI. Here's some additional security IDE plugins that you can look at. There's Clockwork, Sentinel, RIPS Security Analysis, Synopsys Code Site, Secure Assist, DevNox, Veracode Greenlight, Checkmarks, Reshift Security, HCL AppScan on Cloud, SNCC, and PVS Studio. Now, there may be new ones out there since we've done this. If we've missed some, I'm sorry. But there are plenty of these types of apps out there for you to kind of sift through and see which ones you like. So let's move on to lesson 2, learn to configure and manage code scanning for the GitHub repository. And we're going to focus on GitHub with this section. So let's set up some code scanning in GitHub. And again, the code scanning allows the DevOps teams to evaluate source code within GitHub repositories to identify security issues and coding errors. Using this scanning, the team can find, triage, and prioritize the remediation process for security issues in their code. Code scanning also helps to block developers from adding new issues to the code. In the GitHub repository, code scanning can be set up either using CodeQL or third-party tools. CodeQL is developed by GitHub, and it automates security checks. Third-party code scanning tools, these tools also provide static analysis results interchange format output for code scanning. Use GitHub Actions to set up the code scanning. Basically, GitHub Actions allow the user to automate this whole workflow of when to do the scans. And you can set up the scanning using GitHub Actions. Under the GitHub repository name, choose Security. Then you navigate to the right side of Code Scanning Alerts and select Set Up Code Scanning. Click on the Set Up This Workflow button. You can edit the workflow if you'd like to customize how code scanning will be done in your project code. When completed, the developer can commit the file if it's a clean load. And you see that on the right. You're setting up code scanning in this window. And the big thing here is you're integrating it into a workflow. Now, let's say that you're in GitHub and you want to do code scanning on multiple repositories. You can use a script to set up code scanning in many repositories at the same time. To use a script for creating pull requests that appends the GitHub Actions workflow to various repositories, follow the below steps. Basically, you clone the Create Action PRs repository to your local system. Using PowerShell, go to the directory of the cloned repository on your workstation. Rename the .env-example file to .env and include a GitHub token with the repository scope. Authorize the token for SSO if required. Verify that the workflows directory contains all workflow files that you require for the integration. This is where you basically check to see if you got the whole list of things that you want to look at as far as the repositories. To install the script, you run the create actions prs.ps1 command. You run, I'll let you read through this instead of reading it back to you as far as the command, but basically you create pull requests for repositories. This will generate pull requests in any repository where you have push permissions. In other words, you have to have update out to those repositories in order for you to be able to yank back from them and do this multiple repository scan. Understanding pull request checks. The code scanning workflow has two entries mentioned in the pull request check section. An entry for the analysis jobs in the workflow and an entry for the results of the analysis. The code scanning analysis checks are labeled as tool name and job name of the trigger. For CodeQL analysis for C++ code, the entry would look like this: CodeQL analyze CPP and pull request as the variables. If the analysis job failed and you'd like to debug the issue, then click on Details to view the logging data. And here you can see the code scanning analysis checks logging data. Did it reach out properly to everything? So, and it says here some checks were not successful. GitHub, after completing the code scanning task, determines if any alerts are generated by the pull request and appends the code scanning results and tool name entry to the checklist. In case you utilize the pull request to add code scanning to the repository, then an analysis not found message is observed in the beginning of this process. Click on Details to view the various categories to a particular analysis. And here in the screen, we found that the analysis for the merge, we found the results of analysis for the merge commit of the pull request. So how do we manage code scanning alerts in the Git repository? After completing the code scanning, the generated alerts will be displayed in the repository's security view. By default, code scanning will examine the code on the default branch and at the time of the pull request. If you configure code scanning as a pull request check, then the code scanning will be done on every pull request subsequent to it. When merging the changes to the code creates new code scanning alerts to the target branch, it will be notified as check results in the pull request. What do the alert details look like? Every alert identifies an issue with the code with the name of the tool that detected it. The DevSecOps team can observe the line of code that caused the alert and its properties, such as severity, the nature of the vulnerability, etc. The severity level of an alert can be error, warning, or note. Severity levels of alerts can be labeled as critical, high, medium, or low. A category label related to the alert's location is assigned to alerts that are not found in the application code. So here we see a file path marked as library code here. It was a cross-site scripting vulnerability that was discovered. So how do we view alerts in the repository? Basically, a user having read permission for that repository can view annotations of the code scan on a pull request. The code scanning alert page displays the alerts for the default branch. To explore the code scanning alerts, go to your GitHub repository main page and click on Security. Click on Code Scanning Alert and then select the alert that you would like to examine. CodeQL Analysis Alerts has information about the problem. Click on Show More to know how to fix it, so it'll give you remediation steps as well. If there are many alerts and you would like to focus on some specific alert, you can filter the alerts that are displayed in the Code Scanning Alerts view. So over on the left, you have Code Scanning Alerts, exploring the alerts, and filtering those alerts. You can also search the code for scanning alerts. Searching code scanning alerts can be beneficial if your repository contains a ton of these things, or you don't know the specific name of an alert. The free text search in GitHub repository can be done through the alert name, description of the alert, or details of the alert. To search code scanning alerts, Go to the repository's main page in GitHub and select Security under your repository's name. Click Code Scanning Alerts in the left sidebar to view the alerts. Enter the keywords in the search box and click Return. Open source scanning alerts that meet your search criteria will be listed in the alert list. On the right, you can see searching for code scanning alerts. You put in OpenSQL or injection as your criteria. So how do we fix alerts, or how do we manage them? If code scanning detects an issue in a pull request, inspect the marked code and fix the alert. It's that simple. A user with write permission to the repository can resolve an alert by rectifying the code. If code scanning is scheduled to run on the pull request, raising a pull request with the correction will enable code scanning to analyze the changes and test that the correction does not create any new problems. If the user has write permission for the repository, then the user can see fixed alerts by looking at the summary of alerts and clicking Closed. Fixed alerts and the alerts that are rejected by the user can be viewed in the closed list. The branch option on the summary of alerts allows you to check whether an alert is fixed in a specific branch. And you can see there with the pop-up of how to fix an alert. So how do we dismiss or delete an alert? Basically, there are two methods for closing an alert. You solve the issue in the code, or you dismiss the alert. A user with repository admin privilege can delete alerts. Dismissing an alert is an approach of eliminating an alert that does not require attention. To delete alerts, go to the repository's main page in GitHub and click Security under your repository's name. Click Code Scanning Alerts in the left sidebar and select the checkboxes of the alerts and click Delete. To dismiss an alert, first examine the alert and then click Dismiss and select a reason for dismissing it. So in this learning objective, we're going to integrate and scan source code repositories. We'll look at integrating Bitbucket repository with Eclipse IDE. Bitbucket is a distributed version control system that offers free, unlimited private repositories, and it can be easily integrated with third-party tools to enhance the code quality. It provides the teams a single place for project planning and collaboration for coding, testing, and deploying software applications. Bitbucket's integration with Eclipse IDE makes the code sharing much, much easier. So to integrate the Bitbucket repository with Eclipse, you first create an account in Bitbucket and link the Eclipse IDE to the Bitbucket remote repository. You then commit the application code from your Eclipse IDE to that local repository and push the code to the Bitbucket remote repository. You can see the actions down here below, integrating it and pushing the repository to Bitbucket. Secure Bitbucket server repository by integrating it with SonarQube. So what do we do with this Bitbucket that's been pushed to now at this point? We can take SonarQube's integration with Bitbucket server, and that will secure the Bitbucket server repositories and enhance code quality. The integration will allow the DevSecOps team to import the Bitbucket server repository and check the quality gate status and results of the code metrics in the Bitbucket server. This will help the team to know whether it is safe to merge changes or not. To integrate SonarQube with a Bitbucket server repository, add the server configuration of SonarQube in Sonar for the Bitbucket application. Then configure and run Sonar analysis and enable Sonar for Bitbucket. So you can also integrate the GitHub repository with the Visual Studio Code. Git, as we all know, is an open source version control system that allows several developers to simultaneously make changes to web pages. GitHub is a web-based interface that utilizes the Git and allows developers to work on one project simultaneously while minimizing the risk of conflicting or duplicative work. And it also helps to reduce the production time for an application. Using Git from within the VS Code or the Visual Studio Code can improve the efficiency and reliability of the workflow. To integrate a GitHub repository with Visual Studio Code, install Git on your system. Then create an account on the GitHub repository, install the Visual Studio Code, and ensure that Git enabled is checked under the settings. So on the left, you can see enabling Git in the Visual Studio Code. and pushing the repository to GitHub. You can scan the GitHub repository using CodeQL. CodeQL is the scanning feature of a GitHub repository that allows the DevSecOps team to detect security vulnerabilities and coding errors in their application code. The CodeQL analysis workflow can be configured to scan code on a schedule or when certain events occur within a repository. Access CodeQL from the Security tab in the GitHub repository and set up your CodeQL workflow. On the left, you can see setting up the workflow of when this kicks off, and on the right, you can see the results of a scan report. Integrate and scan a GitHub repository using Codacy. Codacy is another automatic code analysis and quality tool that assists the DevOps teams in delivering robust software quickly. To establish the GitHub integration, log into Codacy and navigate to the repository settings. Next, you click on the Integrations tab and choose GitHub. Go to Add Project and add the new GitHub repository for scanning. Scanning the project stored in the GitHub repository using Codacy allows the DevSecOps team to identify vulnerabilities in the code, find duplicated code, analyze code coverage, etc. So on the left, you can see enabling the GitHub integration for Codacy, and the right is the issue report that's generated within it. You can also scan the GitHub repository using SNCC. SNCC is another tool that can check and monitor application code for security flaws. The DevSecOps team can integrate GitHub with SNCC to perform continuous security scanning throughout all integrated repositories, detect vulnerabilities in the open source components, and deliver automated solutions. Log into your SNCC account and navigate to the integration page and select GitHub. Then import the GitHub repositories into SNCC to start the scans. You can see integrating GitHub on the left with SNCC and running the scans. Once they're imported, they're run, and you see the report on the right side. What about AWS Code Commit with Eclipse? AWS Code Commit, as we've mentioned before, is the Amazon Web Services hosted version control tool that developers can use to manage and store assets in the cloud. Code commit repositories are secured both in transit and at rest. Integrating Code Commit in Eclipse allows developers to clone existing repositories, create new repositories, commit code changes, and publish them to a repository. You can install the AWS toolkit for Eclipse, then connect it to Code Commit. And on the left, you see initializing the AWS Code Commit in Eclipse, and on the right, committing changes to the AWS Code Commit. So what about SNCC with AWS Code Commit? DevOps teams have the option to integrate SNCC with AWS Code Commit to monitor and remediate vulnerabilities in code repositories. Use the CDK construct that leverages the SNCC CLI for scanning open source vulnerabilities in Python packages. This construct will scan the input of the code commit repository with the organization ID and the authentication token of SNCC. On the SNCC console, generate the organization ID and authentication token in the code commit repository, then create a file called requirements.txt. Consists of hypothetical vulnerability packages. So then you clone the CDK code and deploy the stack. This results in a new pipeline in the AWS account. The scan results can be viewed on the SNCC console at this point. So on the left, you're creating the organization ID and authentication tokens in the SNCC console, run the scan, and here's the report that's generated in SNCC. What about Azure Repos with Visual Studio Code? Azure Repos is a collection of version control tools for managing code. The integration of Azure Repos with Visual Studio Code manages code changes across the software development teams. To integrate Azure Repo to this Visual Studio Code, go to the respective project in Azure repositories and copy the URL from the clone button. In the Visual Studio Code palette, select Clone from GitHub and paste the URL, then press the Enter button. Down here on the left, you see integrating it with VS Code and changes committed in the Azure repository. Integrating and scanning Azure repos using SNCC. The DevSecOps teams can integrate SNCC with Azure repos at this point to scan for any security vulnerabilities in the source code in an Azure repository. You navigate to the Integrations tab and select Azure Repos on the SNCC web console. This will let you configure the Azure Repos integration. To start the scan of selected Azure repositories, go to Projects and just click Add Projects. So you see it on the left, you're enabling Azure repositories integration with SNCC. You do that, it runs this scan, and it gives you the report. Lesson number 4, learn to integrate secrets management tools. There's a need to integrate secret management tools in the CI/CD pipeline. We've talked a little bit about them in the past, but common sources of data breaches and cybersecurity attacks include exposed data and secrets. It's very critical for the organization to secure confidential information, such as API keys, passwords, authentication tokens, SSH keys, etc., particularly within this development environment. All of these applications and connections have these keys or authentication mechanisms that are required for them to connect. By integrating secret management into the CI/CD pipeline, organizations can manage the secret information of an application in various phases of the development lifecycle and provide granular access to each secret. Secret management tools provide secret storage, key, and identity management. Common secret management tools include HashiCorp Vault, Docker Secrets, Azure Key Vault, and Amazon KMS. Let's look at HashiCorp and how it integrates with Jenkins. To access the Vault from Jenkins, you install a HashiCorp Vault plugin and run the Vault instance. Like I said, Jenkins is very plug-in, kind of modular when it comes down to it. Then select the authentication method, such as app role, GitHub, Kubernetes, etc. The app role authentication method allows applications to access the Vault with predefined roles. Enabling app role gives access for creating a role and getting the role ID. To integrate and connect a Jenkins application to the Vault, perform the following tasks. Here's your command to enable the app role authentication, the command to create a role, the command for getting a role ID, and for getting a secret ID. I'm not going to read through each one of these commands. Hopefully you get to play with it in the lab or at your home. With HashiCorp integration of the Jenkins, we can look at the Vault app role credential at this point, and we can see the plugin configuration page. Conjur is a secret management tool that hides and manages secret credentials. Integrating Conjur secret management tool into the CI/CD pipeline helps to secure the secret credentials in various phases of the development cycle. To integrate Conjur with Jenkins, download conjur.hpi and upload it into the Jenkins plugins. After successful installation, configure the Conjur plugin to define the Jenkins host and generate API keys. Declaring the variables in Conjur policy gives the appropriate privileges to the Jenkins layer to access those variables. After declaring the variables, set values using the following command, and I'll let you read it instead of reading it to you, but it's basically your Conjur variable set command. To configure the Jenkins connection with Conjur, edit the global credentials section in Jenkins with the proper credentials that the Jenkins host uses to log into Conjur. Then configure the Conjur connection information for proper integration of Conjur with Jenkins. And on the right, you can see the secret credentials management with Conjur in Jenkins. So let's talk about Vault. And Vault is another tool that manages secrets and protects sensitive data. It secures, stores, and tightly controls access to tokens, passwords, certificates, and encryption keys for protecting secrets and other sensitive data using a user interface, CLI, or HTTP API. And here you can see the Access tab for Vault. and what it kind of looks like. It's fairly straightforward and simple application to use. Another one is KeyWiz. Again, it's a system for managing and distributing secrets. KeyWiz servers in a cluster centrally store secrets encrypted in a database. Clients use mutually authenticated TLS or MTLS to retrieve secrets to which they have access. Authenticated users can administer KeyWiz via the command line interface. To enable workflows, KeyWiz has automation APIs over MTLS, and you can see the dashboard of it there in the graphic. A good secret management tool for AWS is the, of course, in-house AWS Secrets Manager. Secrets Manager enables the team to control access to secrets using fine-grained permissions and audit secret rotations centrally for resources in AWS Cloud, third-party services, or even on-premises. On the right, you can see the AWS Secrets Manager user interface. Let's say that we want to integrate AWS Secret Manager with Jenkins. So basically, AWS Secret Manager acts like a centralized secret service manager for the entire CI/CD pipeline and stores secret credentials securely. To integrate AWS Secret Manager with Jenkins, install the AWS Secret Manager Credentials Provider plugin in Jenkins and configure an IAM or an Identity and Access Management policy in AWS that allows Jenkins to take screenshots from AWS Secret Manager. You then configure Jenkins for the authentication with AWS by adding the etc sysconfig Jenkins file and adding access ID and secret key parameters to the file along with the region. You restart Jenkins to complete the integration of AWS Secret Manager with Jenkins. And here you can see adding the ID and secret key to the Jenkins config file. Microsoft also has their Azure Key Vault. It safeguards cryptographic keys and other secrets used by cloud apps and services. It increases security and control over keys and passwords, creates and imports encryption keys in minutes, uses FIPS 140-2 Level 2 and 3 validated HSMs, and simplifies and automates the tasks for SSL and TLS certificates, etc. And here you can see a screenshot of the user interface for the Microsoft Azure Key Vault. Azure Key Vault integration with Jenkins. Integrating Azure Key Vault with Jenkins will make the management of secret credentials in the CI/CD pipeline easier, of course. That's why we do it. To start the integration process, create the Azure Key Vault and create a secret within it. Make sure to install the Azure Key Vault plugin in Jenkins and select Manage Jenkins. Click on Configure System and add the Azure Key Vault URL to the Jenkins configuration. Next, you create new credentials as shown below in the graphic in Global Credentials Unrestricted to complete the Azure Key Vault integration with Jenkins. Let's move on to Lesson 5. Learn to integrate software composition analysis tools. So let's talk about a little bit about SCA in the CI/CD pipeline. In the DevOps environment, developers relied on open source or third-party components to develop and release software products quickly. Creating component functionality from scratch takes a long time. So I guarantee you're going to have open source running in your environments. If there is a security issue in the open source or third-party component, which the developer team might not be aware of or they failed to address during the software development process, then that security issue will be incorporated in the application and probably put that application at risk. So there is a need to integrate software component analysis tools that scan dependencies in the project, identify security issues, and provide recommendations for remediation. Let's look at Sonatype Nexus IQ plugin for the Eclipse development environment. Nexus IQ plugin for Eclipse can be used to scan application code for open source dependencies and look at the security issues and policy violations within them. It provides actionable insights and remediation recommendations for detected security issues. Installing Sonatype Nexus IQ in Eclipse requires the addition of a new software repository. Select Install New Software from the Help menu in the Eclipse IDE and click the Add button. Provide this following URL, the download sonatype.com, in the Location section. Select Other in the Show View option from the window menu and choose the Nexus IQ for Eclipse area with Component Info. In the top right-hand corner of the component view, press the Configure button, then add the user authentication and Nexus IQ server URL. So on the left, you can see the component information. On the right, configuring the Nexus IQ server. So the next thing you can do is go ahead and run component analysis. And you see that in the top screen there. You can get the component details as far as what was found in it, and then update dependency versions on the right. Another SCA tool that you can use is Retire.js. Retire.js helps DevSecOps engineers find known vulnerabilities in JavaScript libraries for web and Node.js applications. And here you can see the basic kind of an output from Retire and what it found in a run. Retire.js includes command line scanner to scan a web or Node application for susceptible JavaScript libraries and Node modules. You have the Grunt plugin. It can scan the Grunt-enabled application for susceptible JavaScript library and code modules. Now, Grunt's a command line JavaScript task runner that uses Node.js, uses the Node.js platform. Basically, it runs custom-defined repetitious tasks and manages process and automation. Moving on, we have the Chrome and Firefox extension. It can run sites for references to vulnerable libraries and send warnings to the developer. And Retire.js can be used as a plugin for Burp and OWASP Zap tools. All right, so let's look at the Grunt Retire.js combination, and we look at running a scan. The Grunt task for Retire.js scans the JavaScript libraries for known vulnerabilities by using the Grunt Retire plugin. Executing Grunt Retire allows the DevSecOps team to scan files for dependencies and look at vulnerability libraries. And you can see this down here in the graphic and what it looks like. We'll move on to integrating SCA tools with source code repositories. We'll look at white source for GitHub.com integration with the GitHub repository. White source for GitHub.com is an application for the GitHub that scans all repositories, identifies security issues in the open source components, and provides recommendations for security issue remediation. It supports both public and private repositories. So on the left, you can see installing GitHub tool for white source, and on the right is your configuration tool for it. A white source scan is initiated via valid GitHub push command, so you can actually have these automated. The valid push command meets at least one of the following requirements. A white source supported extension was added or removed by a commit of the push command. The package manager dependency files have been altered by a commit of the push command. So on the left, you can see the initiation of the scan. You can see checks failed due to security issues, and initiating the security checks is in the fifth block. And the detected vulnerabilities can be passed through email with this system. So you get automatic kind of notifications that go out to the developer, security team, etc. Then let's look at SNCC integrations with Bitbucket cloud repositories. Integrate SNCC with Bitbucket cloud repositories to perform continuous scanning, identify vulnerabilities in open source components, and fix the vulnerabilities automatically. SNCC can access a Bitbucket account if its user can create a dedicated service account in Bitbucket with admin permissions. So on the left, to scan Bitbucket cloud repositories using SNCC, you select Add your Bitbucket cloud repositories to SNCC. Select target repositories and start importing them to SNCC. Click Add Selected Repositories to make that connection. SNCC will start scanning dependencies in the selected repositories. The repositories will be imported on SNCC as projects. Imported projects will be displayed on a projects page. They'll be checked for vulnerabilities, and the security report will be created at that time. So here on the left, we see updating Bitbucket and successful connection established with Bitbucket on the right. Let's learn to integrate SCA tools with Travis CI, Jenkins, and GitLab. So now we'll look at configuring Bundle Audit in Travis CI. You'd configure Bundle Audit in Travis CI to receive security issue alerts and recommendations for fixing them. Use Travis's cron feature to run CI on a regular basis, which will alert the team in case the builder audit fails. Basically, a cron refers to cron jobs. It's a nifty little feature in the Unix operating systems that lets you schedule any command to be run at any time. You configure Bundle Audit in Travis CI using the following script, and I'll let you kind of read through that for a minute. All right, let's move on. This integration, debricked with Jenkins, allows you to perform a vulnerability scan whenever the pipeline triggers it. So it's another automatic scan tool. You do this by adding a new stage to the Jenkins file in your repository. Edit the example Jenkins in the code in the Jenkins file with the project name and add user credentials for debricked in Jenkins. After completing all changes and committing this file, a vulnerability scan will be performed at the pipeline trigger event. And so basically you see the Jenkins, the code of the Jenkins file on the left and the credentials for debricked in Jenkins on the right. Now we'll look at using check marks to perform SCA scan on GitLab project code. The check marks integration with GitLab enables the DevSecOps teams with another option for detecting new security vulnerabilities early on. Before integrating the check marks SCA tool with GitLab, run the required environment variables in GitLab. The root directory of the project has a .gitlab-ci.yml file, a YAML, which controls GitLab's CI/CD pipeline. To use the checkmarks template containing jobs defined for the pipeline, you add the following URL, and I'll let you just kind of look at it. Define the variable in the GitLab CI YAML file in case you want to override the parameter, then click on Commit Changes. And here we look at the template that's to be included on the left and the configuration of the software component analysis on the right. To scan GitLab project code, select the project, commit changes for the merge request, and submit that merge request. Click on CI/CD in the menu bar, then click on Pipeline and check the merge request status. After the merge request is finished, go to Merge Request in the menu bar. You scroll down and you can find the checkmark summary of the SCA results. So on the left, you see a scan being run by checkmarks and the results and output on the right. Let's look at SCA tools with AWS. So we can integrate the SNCC tool with an AWS code pipeline to scan the software code for open source vulnerabilities. The tool supports various languages such as Java, .NET, Python, Ruby, and others. The DevOps team can add a SNCC scan after the source stage to test the application at various phases in the CI/CD pipeline. After naming the action, choose SNCC as the action provider. You connect to SNCC, then configure the settings. Finally, view the scan results in the AWS code pipeline console. So on the left, you see the configuration of it and a successful scan that was run by SNCC. Integrating the Black Duck tool with AWS Cloud provides another combination for finding vulnerabilities in code. You use Azure Marketplace to integrate Black Duck SCA. Create custom actions of the Black Duck scan code pipeline, then create the necessary identity and access management policies. Create a Black Duck scan job worker for custom actions. Then you can edit or create the pipeline and add the custom action as a test stage and release in the pipeline. Navigate to the Black Duck interface to get the detailed Black Duck results. On the left, you can see the configuration of it, and on the right, the Black Duck results. Black Duck software composition analysis helps teams to manage the security quality and license compliance risks that come from the use of open source and third-party code in applications and containers. The DevSecOps team deploying Black Duck in their AWS cloud environment can scan their cloud applications and images in the container registry and receive notification about policy violations or security vulnerabilities. And this is what the Black Duck dashboard looks like to be able to configure everything that you need to. Let's talk about White Source SCA tool integration with AWS. You can integrate White Source SCA with AWS Cloud to detect security issues in the open source components and to prevent incorporation of vulnerable components into the application through automated enforcement of your security policies. To ensure integration of AWS code build applications with White Source, the build must be set up in a Linux environment. On the left, you can see editing the build spec, and on the right, there's a sample build spec YAML file with White Source integration. Activate the White Source scan by starting a new build, which is where you take your code and you create a standalone application or object within the environment. And then the scanning results can be viewed in the White Source organization under project. And you can see this output had some problems with that particular scan. Let's learn to integrate SCA tools with Azure. OWASP Dependency Check is a software composition analysis tool that detects publicly disclosed vulnerabilities in Microsoft Azure project dependencies. DevSecOps engineers use Dependency Check for detecting common platform enumeration or CPE identifiers for a given dependency and generate a CVE entry report. We've all seen CVEs. The CPE is the common platform enumeration. It's a standardized method of describing and identifying classes of applications, operating systems, and hardware devices present among an enterprise compute resources. So anyways, down here we can see the output of a test, the results of a test that was run. As we said before, OWASP Dependency Check scans a project for well-known and publicly disclosed vulnerabilities in a project and can display the results in whatever format that you desire, HTML, JSON, etc. The OWASP Dependency Check extension can be installed and downloaded from Azure Marketplace. On the left, you can see adding OWASP dependency checks to your pipeline and your workflows. On the right, once the event triggers, you can see the scan results that are put out by OWASP. So what about using SNCC with Azure? SNCC scans your application dependency and container images for open source vulnerabilities, much like all the tools that we've talked about so far. It can be seamlessly added to your continuous integration, continuous delivery workflow. Configure a service connection endpoint with a valid SNCC token after installing the extension in the Azure DevOps setup. Add the SNCC security scan test to an Azure DevOps pipeline and configure it. So on the left, we see installing the SNCC extension and configuring it on the right. With SNCC security scan for Azure Pipelines tasks, you can quickly add SNCC scanning to your pipelines to test and monitor for vulnerabilities within the CI/CD workflow. Here we see a report that's generated from the SNCC scanning with a fail, obvious one. So there are some additional SCA tools that are available out there. We talked a little bit about Retire.js, but there's Dependency Check for Java, Nancy for Golang, NPM Audit for JavaScript, Safety from PYUP, which is Python, .NET CLI for .NET, Bundler Audit for Ruby. You have Local PHP Security Checker, and White Source Bolt for .NET applications. Others that we talked about or that are available include SNCC, Sonatype, Contrast Security, White Hat SCA, Debricked, White Source, Black Duck, and SourceClear. So let's go through a real quick module summary with what we've talked about. Developers are responsible for mitigating the vulnerabilities caused by their code. Having secure plugins in the development environments enables developers to check for security flaws while they code. It's very critical for an organization to secure confidential information, such as API keys, passwords, zero auth tokens, SSH keys, etc. By integrating secret management into the CI/CD pipeline, organizations can manage the secret information of an application throughout the development lifecycle and provide granular access to each secret. You want to integrate software component analysis tools that can scan dependencies in the project, identify security issues with those dependencies, and provide recommendations for remediation. So this wraps up Module 4. Thanks for paying attention, and we'll see you in Module 5.